Okay, so first I wanted to tell you that the API Platform Conference means a lot to me. Indeed, 4 years ago I was just here, because the room was oriented differently, and doing my very first talk. And then I never stopped giving some conferences, so yeah, I'm quite glad, to be here. And it's funny because my first talk was already about API platform and serialization. I was explaining how to configure serialization using API platform. And since then, I kind of never stopped working on that topic. And that's why today I'm going to talk about API platform, serialization, and performance. Okay. A bit about myself. My name is Mathias Arlaud. I'm a French PHP developer, as you might have heard. I'm the co-founder of Backslash, the company with the logo on the lanyard. Kind of proud. And yeah, I do love to do open source. And when I do so, I work on Symfony, API platform, this kind of ecosystem. And I mainly work on serialization and metadata. That's why I'm able to talk on that topic. So first, the first things to do is to understand what serialization is for real, you know? So let's take a step back and let's, see the fundamental. Again, this slide, 4 years ago, I used that slide, that very slide. So I hope I'm still able to explain it to you. So the serialization is the fact of representing data structure in a format that can be sent or persisted so that it can be reconstructed later. It's quite a dense definition, so let's look at the key points of that definition. Representing data structures is like creating a construction pattern of these data structures so that we are able to reconstruct them later on. And the reconstruct later part is the important part, because we must be able to reconstruct the data structure later, elsewhere, and even using another programmation language, you know. And this is what enabling the interoperability between systems. So it's kind of important. To do that, we represent them in a format. We put them in series, okay, serialization. And this format can be binary, such as protobuf, which implies speed, lightness, or another textual, which implies editability and comprehensibility, such as JSON, XML, and so on. And then, we store that in database, or we can send or receive it through API, which is interesting us. Okay, so to make things really, really clear, in the API world, when we try to retrieve a resource, for example, the cat1, the data structure cat1 is in memory at some time, you know? And the act of serialization is to convert that data structure, into a JSON string. Simple. Much simpler than the previous definition. On the other way, the same goes for the deserialization in the API world. When you submit your own version of an resource in order to create one, update one, and stuff, you provide a JSON string in the content of the request. And the act of deserialization is to convert that JSON string to an actual data structure that can be manipulated by the application, right? Okay, so in API platform world, when you try, for example, to get a cat, this is what happens since the recent version of API platform. A collection of providers are calling each other in order to retrieve the data, the cat one. Okay? And then a collection of processors will process that data in order to convert it into an HTTP response. And among all these processors, there is one, the serialized processor, which is responsible to convert our cat to a JSON string. And this serialized processor is relying on Symfony Serializer. On the other hand, when you try to post a new cat, a collection of providers will read the JSON provided in the request and to convert it to a real cat. So the provider involved to deserialize the JSON is a deserialized provider and is relying as well on Symfony Serializer. So we can assume at the moment that API platform is tightly bound to Symfony Serializer. And consequently, the performance of API platform is directly linked to Symfony's serializer performance. So let's focus on Symfony Serializer for a little while. If you ever went to the Symfony documentation about the serialization, you might have seen this schema, right? So this schema told us that the serialization in Symfony can be decomposed in two main steps, the normalization and the encoding, okay? The normalization first is the fact to convert the initial data structure to a normal form. A normal form is like, you know, it's like converting the data structure so that it has the shape and the content we want in the final data stream. So this data, this normalized data, is just an array in Symfony with the shape and the content we want in the final stream. And then we take the normalized data and we encode it so that we have the final data stream. On the other hand, of course, the deserialization is the exact opposite. We take the string, we decode it so that we have an array, okay, the normalized data, and then we denormalize it so we get the initial data structure. Okay, so as you might have guessed, all the R stuff is being done during the normalization step. Indeed, it is during that phase that we will work on the cat to change its shape or its content. For example, here we say, okay, when we normalize the cat, we will just count the mustaches. We will capitalize the name, we won't keep the ID, etc., etc., etc. And the same goes for the deserialization. Of course, the hard work is being done, during the denormalization step. Indeed, during that part, we will take our array, we will instantiate a new cat, or take one, and then we will move the data. We'll create n default mustaches and create clause according to the aggressivity of the cat, and etc. So the thing to remind here is, like, all the R stuff is being done during the normalization and the denormalization step. Okay, so let's see a little bit of PHP, of course. Let's focus on the normalization, but from the PHP point of view. So let's say we have a cat class, right? And this cat class has some properties, an ID, a nickname, mustaches, etc. Let's see how Symfony Serializer behaves during the normalization. For the ID property, for example, the serializer will read, PHP attributes and understand what he has to do. So first he will ask, can I read the ID? And because of the in your PHP attribute, the answer is no, so yeah, the normalization stops there. For the name, same, it will read PHP attribute and it asks, can I read the nickname? Because it's private, it knows that it can't read using the property directly, so he uses the aggregator, but yeah. Then he asks if it has to do anything with the key, and because of the serialized name, the key in the normalized data won't be nickname, but it will be name, and with the value, it has nothing to do. And finally, for mustaches, he knows that he can read mustaches. He hasn't to do nothing in particular with the key in the normalized data. And for the value, because it has read the PHP documentation, he knows that the mustaches array is not just a raw array, but is rather a list of mustaches, of objects. Therefore, instead of just serializing the array, it will iterate over the array and normalize each object one by one. So a lot of stuff is being done during the normalization step, okay? And plus, it's still not over. Let's say that we wanted to create a custom normalizer to tweak a little more the normalization. Indeed, we can create a cat mustache normalizer, and this normalizer will be called for each cat. And this normalizer will call the regular Symfony normalizer, which is doing all the stuff we've seen just earlier, and then manipulate the normalized data so that it replaces the mustaches by the count of the collection. Okay? And we are finally done. So we are doing a lot of stuff during normalization, and stuff takes time. And that's why the serialization is most of the time quite slow. And to improve a bit the performances, Symfony is using cache. It's caching a lot of steps. So it improves a little bit performances, but still serialization stays a bottleneck of API platform applications. Okay, I'm gonna open a little parenthesis. We are going to talk a lot about metadata during that talk. So what I would like to do is to take 5 minutes to make sure that we all understand what metadata is. If we had to describe the metadata in one sentence, we would say that metadata is data, but it's data about other data, dataception. As a matter of fact, the more metadata we have in terms of quality or quantity, the better we'll be able to interact with the initial data. Because we'll, of course, understand much more that data. So let's take a little example. Okay, let's imagine that this blobby thing is our data, but described by the metadata. So if the metadata said about the data that this is a thing, we won't be able to do anything special with that thing because it's way too blurry for us, of course. But then, if the metadata tells that we have to deal with an animal, we can deduce that, yeah, it's a living being, so we have to take care of it and stuff. It's less blurry. Then, if the metadata tells us that the data is a cat, we can now make it happy by offering it some milk, just a little. And if finally the metadata tells that the data is a flying cat, we'll immediately take shelter to avoid being under its claws when that cat lands, of course. So, as you can see, the better the metadata is, the more consistent we can be with the data when interactive with it. And this is exactly the same in PHP. Okay, back to our well-known PHP world. Let's suppose that we have a class here that is representing the rain. And let's say that it is possible to define generically, using generics, what's going to fall on us, which is stored in $phonic stuff. So we're going to focus on the metadata describing what's going to fall on us, $phonic stuff. If we start from scratch, we don't know anything about that rain content, okay? And now let's suppose that we want to serialize that $phonic stuff in JSON, but only using the guest type, right? For the moment, because we have no idea of the type, the JSON could be literally anything. $phonic stuff could be a Boolean, a dictionary, a list of floating numbers, and so on. But the more precise our type will be, the more we'll be able to guess what shape the JSON might take. For example, if we know that $phonic stuff is an array of something, we now are sure that the JSON will begin and end with a curly or a square bracket. If we know that this is a list of something, we are now sure that it will begin and end with a square bracket. And if we know that the $phonic stuff is a list of cat and dog, we'll now be sure that it will begin and end with a square bracket, and each element of the list will be either the string cat or the string dog. So as you can see, the metadata type could be a very interesting piece of information when it comes to serialization. And in Symfony, to retrieve a type, we use the property type extractor service. And from this service, we can easily retrieve types of a property of a given object, okay? So the method getTypes will return an array of the types that the property can have. Unfortunately, this service is way too often too limited for what we want to do. According to its name, property type extractor, it's limited to property only. And when multiple types are involved, it returns an array, but we have no clue if it was an union or an intersection. And we know that it's quite different. And when it is an array, we can't know if it's a list or dictionary or whatever, and it cannot read generics and so on and so on. For example, here it was what the property info can read about a class. Only the property. Okay? It's not that much. And that's why Mathias Arlaud and I decided to rethink the metadata about type in Symfony. And in November, we have opened a PR, introducing a brand new component, which is the type info component. And it has been merged in 7.1, so that's great. I have not that much time, so I won't dwell about that component, but aside, what I can say, it's like, aside a better type definition, the type info can read and understand much more stuff. As you can see, it can still read properties, but it can read return type of method, and it can read the type of argument of a method, and it can read PHP doc and understand generics, and so on and so on. And so this leads to a way better understanding about the class and the class definition. Yeah. So that's why with type info, our data is now much more clearer. And this is great for our issue. And you will understand more a bit later. So yeah, with type info, we have a much more better definition about our data. And this is great. Okay, parenthesis closed. Now that the metadata is clear, I wanted to talk about the biggest limitation of Symfony Serializer, which is the memory limitation. You remember that schema? It explains how the serialization basically works. So, as a reminder, when you serialize something, you normalize it. So you create an array that is in memory, and then you encode that array. But let's say that now you have a huge collection of objects. It means that during the normalization step, you will have a really, really big array in memory. And of course, the bigger the collection will be, the bigger space you will take in memory. And at some point, you will reach your application limit, and you will have an out of memory issue, because you won't have enough memory to serialize that huge collection of objects. To fix that issue, there is a solution, which consists of going through the data and to write directly into the stream, the serialized stream. This is what we call streaming. And the streaming is really great because it allows you to serialize a huge collection, a huge amount of data with a constant memory usage. Unfortunately, as you have seen, with the current state and the current design of the Symfony Serializer, we cannot leverage any streaming. I told you that this conference means a lot to me, and I didn't lie to you. Indeed, it's me on that picture. In the other room, not listening the conference, but submitting this instead. So this is a new component proposal, the JSON encoder component. And the only purpose of this component is to serialize data from and to JSON as fast as possible, as efficiently as possible, of course, while being able to do streams, okay, and to be flexible enough to meet most of the use cases. So let's see how it does work. Let's go back to serialization. Let's imagine that we want to serialize a cat again. Thanks to type info, we have a very precise metadata about the cat class. And so we can greatly anticipate what the cat will look like when it will be serialized in JSON format. Indeed, we are sure that it will begin with a curly bracket, have then the string name, then a colon, then any string inside, and then a comma, and then the flying string, then a colon, then either true or either false, and then a closing curly bracket. And what it is interesting here, it's what I said is true regardless of the cat that we want to serialize. And this is the interesting point. Because now that we are able to predict the JSON shape in advance, and therefore we are able to write it step by step. Indeed, let's say that we want to serialize this collection of two cats. We'll be sure that it will begin like that. Okay? So we can write it statically. Then we load the cat in memory, and we fill the gap. Okay? Part by part. And then it's over with the first cat. We write the static string, and we load the second cat. And we fill the dynamic part. And then, over. So, as you might have seen, at any step we have at most one cat in memory. And plus, if the output is a stream, the serialized data won't be at all in memory. So it's huge in terms of memory usage. The memory usage will be flat and flat and flat. And this, no matter the collection size. So this is quite good. And to do that, in PHP, it's quite simple. We can just write a PHP function that takes cat, stream, and some config in parameters, and to write part by part into the string. So thanks to type info, we are able to write some static parts. You see, curly bracket, name colon. This is gets in advance, and we have some dynamics part related to a specific cat. So this function, from now on, we're gonna call it encoder. Okay? So now that we are able to serialize in JSON using stream, this is great, and this is fast. But this is not the thing that makes the JSON encoder so fast. Indeed, there is another trick, and this trick lives in the components mode of operation. Indeed, sorry. Okay, so when we use the JSON encoder to serialize a cat, that component will firstly check if an encoder exists. As a reminder, the encoder is that function. If the answer is no, okay, it will call typeinfo and compute the cat shape in JSON. And using that, it will generate and store that famous PHP function, that encoder. And then it will just use it to serialize or encode the cat. But for all of the other cats, the answer to doesn't encoder exist is yes. So serializing a cat will be just calling a PHP function, no computation. So even if the encoder generation part is quite slow, it's done only once and can even be done during cache generation. And so for most of the cats, serializing a cat will be just calling a PHP function. So it's blazing fast. Then if we want to stream in, to do stream in API platform, we just have to go into the serialize processor and to replace the serializer by the JSON encoder. Actually, not completely. We missed something. Do you remember? We have two processors involved in the response creation. And at some point, the serialize processor will give back a string to the response processor, which will use to set the response content. So this means that at some point, the whole string will be in memory. So that's not great. It breaks the stream behavior. Instead, we can create a new processor, the serialize and response processor, that will be using the JSON encoder, and redirect directly the stream into a stream response. So again, limited time together. Well, so it's okay. I'm going fast. So yeah, plenty of advantages. This component is at least 10 times faster than the serializer. It can understand generics, and it can either read and write streams. So you can imagine some use cases like, okay, I'm reading a really, really big JSON file using stream, and process the data using generators and stuff to be able to yield, and then redirect the formatted data and serialize it using the JSON encoder as stream. So you can process very big file, process them with constant memory usage. And we can, when reading, it tokenizes the JSON, so you can read only the part you want, and it can be lazy, so plenty of features. So that's great. But there is one thing that this component cannot do by design. It's to change the object type during serialization. In other words, I cannot take a cat and serializing it as a dog. And this is an issue because with the actual serializer, it's possible to do that. It's because we are able to use custom normalizer, groups, and so on, and so you modify the shape during the serialization. So it's an issue. Okay, in Symfony, we are using groups generally to tweak, the serialization. And for most of the simple use cases, I think it's okay. But actually, I do think that it is kind of a conceptual mistake. And this is fun because 4 years ago, I was telling, hey, groups are great, and it is how you can apply them dynamically, Things changes. Indeed, having 3 groups is like having 8 different representations of the very same class. And in terms of separation of concern, it's not that great. And it goes worse and worse when you add other groups. 4 groups, 16 representation, 5 groups, 32, and so on and so on. A huge cardinality. But I can't blame developer to do that, because it is the traditional and application development way to do and to develop an application. Normally, usually, you create a cat class and you say, oh, I want to store that cat in database. Let's put an ORM entity attribute on that. Great. I would like to expose that cat over an API. Let's put an API resource attribute on top of that. Okay, simple. Oh, I want user to read some stuff of the cat, but not during the writing. So, okay, let's configure the normalization and denormalization context, adding groups specifics to reading and writing, and adding some group attribute on top of properties. So in the end, our cat class is doing way more than one thing. And it's the same as creating this kind of cat, you know, a cat which is either a cook, a painter, and a skater. So yeah, and by doing too much stuff, you likely to be so-so at everything. And moreover, API platform has not been designed for that. The way that the creator of API platform wants us to use is to design our resources first, such as the get, the post, the get collection of whatever, and only then collect the underlying data using providers. It's like creating classes that represent the data that we want to expose, and such as just writing an API documentation using PHP, and only then link with the actual data. And by doing that, we'll be forced to have one representation per resource. And to fix our multitasking cat, it's quite simple. Indeed, we just have to create one class per responsibility. One cat entity for the database storage, one cat get resource for the get operation, for example, and one cat post resource for a post operation. Each one with its own specificity. So it's easy. And each class is now clearer and have just one responsibility. And to switch from one to another, we just have indeed to write a little bit of code. So we can create a custom provider. And this provider is not doing that much. It's calling the provider, the regular provider of doctrine, in order to retrieve the cat entity. And then it creates a cat resource and, you know, do the mapping and do the stuff so that it can, return the cat resource. But converting object to other object is kind of repetitive and can be even considered as boilerplate code. And that's why there is another component proposal made by Antoine, which is the object mapper. The object mapper does exactly what its name suggests. It maps object to object. And so it replaces the boilerplate code of us. So to use that component, it's quite simple. You just put some PHP attributes on top of classes to configure the mapping. Here we say that my cat entity can be mapped to the cat get resource. And when doing so, I'm going to map the ID to the ID of cat resource. And I'm going to map the nickname to the name of cat get resource. And when doing so, I want to transform the value applying a specific function, which is UC first, to capitalize the name. And then we'll just have to use the object mapper. The interface is not existing yet, but it's for the example, to convert the cat entity to the cat resource automatically. If you want to have a deeper and a much better explanation about mapping entity to resources and stuff, you can look on YouTube the very great talk about Ryan Weaver, which is talking about that using state options and stuff, and it's much more precise than me. But it is possible. It is quite simple. And so what I want to say is like keep just one resource per representation and stop mixing stuff up with a group as much as possible. Then, if we are doing all of that, API platform might be a bit faster because the serialization will be a lot faster. Here is a benchmark of the serialization speed. So as you can see, the JSON encoder is 40 times faster than the Serializer. And when you combine it with a mapper, it's something like 10 or 15 times faster. I used here the mapper of Jolly Code, which is a bit more performant because it uses generated code as well. But I'm sure at some point the object mapper will integrate such a feature. So yeah, it's kind of more speedy and while being able to do streams. So this is great, I guess. And the same goes, of course, for deserialization. The JSON encoder is 10 times faster than the Serializer and something like 8 for the deserialization. Okay, so now that we have seen all of that, what's next? As you have seen, this conference is hugely living on the edge. I've shown you a component merged in 7.1, 2 components that has not been merged, still in review, and 1 API platform integration that it is only on my repository. So yeah, you won't be able to try that tomorrow or today, even if I love that. But yeah, therefore you will have to wait a bit, and so yeah, stay tuned and thank you. Thank you.